So the recommended way of using dynamic memory is in classes, because we can use the constructor, which we know executes one time when we create a class, and then its complement, a destructor, which executes one time when the class is removed from memory. And when is something removed from memory? Well, if we're using it in a function, then when that function executes and finishes executing, then that class is removed from memory, as long as we don't create dynamic memory for that class, and we'll see examples of that. So it's not as simple as, okay, create dynamic memory in the constructor and then delete it in the destructor and everything's fine. No, we have to put some other constructors and overloaded operators to make sure that we don't leak memory. But then our classes will work like the vector class and the string class, where we minimize the opportunities for creating memory leaks or dangling pointers. Remember, a dangling pointer is we create dynamic memory, and then we have another pointer point to that memory, and then we delete the memory from the first pointer, and we forget to point the second pointer to nothing, and this pointer is pointing to memory that our program no longer references. So that can cause a lot of issues for us too. So, okay, so where am I think it's 9.6. Yeah, right here. So here's where we're going to start our code, and we'll start creating a class, and it'll be a simple vector class, right? I mean, so if not defined, and we'll use my vector, then define my vector, and if, and we create a vector class with capital V, open close curly brace, and public access specifier. Private access specifier, we don't use protected. We're not gonna inherit or anything like that. Okay, so we need to create, well, actually I need two includes. Include, what are they? CST D, and these two includes are for the size of T special. Oops, STD. Okay, with those, then we can use this in the Mac environment and in the Windows environment. I think Mac users, if they didn't include this, then and they tried to use this, then they wouldn't know what size of T was. So, and we name it size. So the size of the array we're going to be working with in here. We create a pointer to elements. That's our pointer to an array we're going to create. And we have one constructor for starters. Size of T, and what is size of T? Again, it's a non-signed integer, meaning numbers start at 1 and go up to, I think, like 4 billion or something like that, and no zeros or no negative numbers. Okay, so we have our constructor. We will provide the constructor code in the CPP because it'll be more than one line. Okay, let me see here. CPP include is there. Let's make this part of our class. And then we have initializer, and we will set our private variable size to the incoming parameter size, and we will initialize our elements pointer to a dynamic array of size SZ. So what happens here? When we create an instance of our class, say with the number 3, then size is set to 3, and we create a dynamic array of 3 elements. And then finally, we will use a loop just to practice with looping, right? To initialize everything to 0, and then plus plus I, everything what? The elements, right? So each element, we will give it an initial value of 0. And if we come to a diagram, here, and I copy that code, well, actually not this code, I go to main, and no, not main yet. Let me first of all diagram what happens. Okay, so we have stack, heap, get some blocks there. So when we create a vector, let me create some free functions here. Okay, so free functions not part of the class. Okay, so not part of the class, and they return nothing. So void use a stack variable vector, and the other one will be use a heap memory vector. We copy the signatures and we'll go over here. Maybe I should copy this too, just to make sure that everyone understands that those are free functions. They are not part of our class. Remove the semicolon, open close curly brace. Same thing over here. And here we simply say, okay, our vector, we name it v1, 3 elements. And then what happens? Okay, so we go to our diagram, and let me copy that code here, just this one. So when that code executes, we'll get a chunk of memory. So we'll say it gets that chunk. So this is v1, and v1 has size of 3, and then it has an element's pointer that as soon as our constructor executes, we initialize that pointer, and somewhere it will create some memory. And we can say that elements now is y50, or meaning it points to this address, and we initialized all of them to 0, and that's how that code looks. Okay, so we can come back to our code, and I'll say include IOStream here, and then we'll say stud cout create and init elements. So come back and look for main. Okay, we found main. Include what is it, vector, so vector.h, and then here we say, okay, let's call the use stack vector so that we can execute this code right here. Okay, so come back here, source examples number 9 unit 6, and we run it. So create and initialize elements. So we create them, but we create memory, the function exits, and then this memory here is still occupied or still in use by our program, because we didn't call delete in any of our class construct, which is not good, but that's okay. Like we'll fix that. So as I said in the introduction, right, we can do that in a special complement to the constructor, and that's the destructor. So we can say, oh, okay, so let's create this guy, and let's write some code right here, make it part of our class, and we say, okay, cout release memory. So we release the memory by calling delete subscript operator and the name of our pointer element. And we come back here and let's see what happens. So we come here and we run. And notice the difference. So the first execution, the first time we ran the program, we created and initialized elements, and then the program exited and we had a memory leak. I mean, temporarily, right? Because once main goes out of scope, then our program's not in memory anymore, but point taken, like we are leaking memory. And once we create the destructor and we add code to remove the elements, then we release memory. So now when our class is used, we don't have to worry ourselves or another developer. We don't have to remember to call delete because we are using class special functions, constructor and destructor, to create. And where are we going to use the memory? Well, in any function in our class. And then once the class is out of scope, then delete is called. In this case, we can understand now that if we create a vector, it's in scope while the class, not the class, the function is executing. Once the function executes, then it's gone. And we can prove that by, let me change this IO stream to here, and we can go here, and we can say before function, and then we will create another one after function, so that we can see like when is the memory being released, right? After function, and we run it again. So notice before function, and then we create memory, we release memory, meaning once this function exits and before this statement executes, the memory is released. So proving that yes, like the destructor is helping us clean up memory, which is what we want. And we didn't have to do anything. Like, I mean, we just had to set it up correctly, but when we use it like the vector class that standard library has, just like this. We just use it. So questions there? And again, these concepts right here, they're very important for data structures and to make you a good programmer, right? So the memory management techniques, they'll help you whether you use Java, C#, Python, or C++. Okay, so now what's this guy? Use heap vector. Okay, so we know that to create dynamic memory, we have to have a pointer, and then we have to use the keyword new. Okay, so that's what we will do. We will say, okay, I want a pointer to vector v1, and then we say equals new vector of 3 elements. So we create dynamic memory for this vector. How will this work? Okay, so let's comment that one out, and then let's use heap vector, and let's run it. So before the function, create and then create memory, but notice after function and then the memory is not released. So what do we need to do to release the memory here? Like, anyone? Like, what do we need to do here in the function? And the answer's in the class itself, like, and I've been saying what to do, right? So pointer, create memory, use memory, delete memory. So we need to delete. We have to call delete ourselves now. We have to delete. And once we do that, we should be okay. But then again, now we are putting the responsibility on ourselves to release memory, right? So before the function, and then create and init elements, release memory, after function. So notice that we have to explicitly call delete to delete the memory from the heap, right? Dynamic memory is always on the heap, right? So that's why I was saying the answers here in the class, right? So create memory, use memory, delete memory. Why is this subscript operator here? Because elements is an array, and here v1 is not an array, it's just a simple variable. I mean, it's dynamic memory, right? But we're not creating an array of vectors. So we have to call delete, and that'll delete it from the heap. So this is the recommended way of working, because v1 does not take up a lot of stack memory, and all its data is going to be on the heap, and then we don't have to remember to call delete when we create v1. We've already set up that construct in the destructor. So we use C++ built-in scope for memory management to help us, and that's what we always want. Like, we want to take advantage of the tool we're using, and that way we give ourselves fewer opportunities to make memory leak errors. Okay, we go to main. I'll comment this before I check it in, but for now we go here and we're like, okay, so let me create a vector of 3 elements, and then I want to create a new vector from the existing vector. Okay, and let's copy the code, and okay, so obviously we're going to need another constructor, right? But we still want to show what happens when these 2 statements execute. So okay, so v1, and then first let's see what happens here. So size will be 3, elements will point to something, and we'll stick to the same numbers. So y and x, right? So So this one points to y50, and we've initialized them to 0. Okay, v2 equals v1, size 3, maybe, yes or no. Well, we gotta investigate that here, and it'll be this once, and then elements, and what will it point to? Okay, so before we see what happens, let's add some more. One function to actually two more functions. Let's see, two. Yeah, we need to add some functions here. We need to return size. So we say size of t, and then we say size constant return size. Okay, so we have that function. So now we can return the size, and we want to see what happens in memory when v2 equals v1 occurs, but we cannot do that without adding some more functionality. We need a way to get the element at 0, the element at 1, and the element at 2. So we have to write some more code, and we will overload the subscript operator. Okay, so what I mean is we need a way to make sure that this code is valid, like that we can say cout v1 of 0, or we can say v1 at element 0 equals something. So we need to make sure that we overload the subscript operator, this guy. We want to overload that to give our class the ability to handle this syntax right here. Okay. So we come here and we are like, okay, return a reference to an integer operator, subscript operator. We put here size, right? Size of ti, and then we return the elements at I. And that should make this one and this one okay, but I think at runtime it'll fail. So we need to add one more. We need to say reference to operator overload size of ti, and then we say, okay, constant return the elements at I. And now that code that I just showed you is supported by our class. So this code now will work. And we need that code to create our test case. Okay, so let's go to test cases, examples 9. Okay, so for now, we will comment this out. Before I check it in, I'll remove the comments. Okay, test case. Test vector. Test create new vector. Create new, let's put a capital V, vector from an existing instance, vector instance. And we come back to main, and we have that code. Okay, so include vector.h. Okay, now we should be okay. Okay, so we need to check first of all when we say v2 equals v1, is size the same? Okay, so check size first. So that one should be easy. We just say, okay, require that v1 dot size equals v2 dot size. And I had already shown an example of this with stack variables of like we create a class that has stack variables, and then we say create a new class from an existing class. And I had already shown that the stack variables are copied. And then at that time I stated that pointers we would have to wait till later, and that time is now. So we'll see what happens. So first, before we write the test case for the pointer, well, let's see if at least this one passes. It's building. And still building. So any questions so far? So far, I've not introduced anything new. Like everything we've done up to this point, we've been able to cover, right? So if we inspect the output, so we created memory one time and we release memory 2 times. So that right there, this is probably a better picture, right? Well, actually that one after function, this one, sorry, this one. So create and initialize elements, but then we release memory twice. So there's something wrong, right? Because they should always complement each other. So there's something wrong. Let's create our test case to check the elements. So we check the size and then we check elements. Okay, so how do we check the elements? Okay, so if it creates new memory for v2, then if we say v1 at position 0 equals 5, all of them are 0 initially, right? So we purposely change it to 5. Then v1 at element 0 should not be equal to v2 at element 0, because there should be there should be another array of 3 elements somewhere here. So let's see what happens. Let me see here. Ran the wrong one. This one. Run in terminal. And it's building. I guess while it builds, I need to get some water. Oh, linking. Okay, so it's linking. And so it failed, right? So now we can conclude where's my diagram? So now we can say, oh, wait a minute. This guy is also pointing to to y50. So it correctly copies size 3, but the pointers it doesn't, right? So the concept of copying stack variables is member-wise copy. And if you think about it, it's trying to help us too with the pointer. Like it copies a pointer too, but it copies also the address that the first pointer is pointing to. So it's trying to do its best to help us, but it messes it up for us, right? So we need to add some code to fix this. We need to create new memory somewhere else. We need to copy these values into somewhere else, right? Even though we know we initialize them to 0, we don't know at what time a vector is going to be copied, right? So we still have to copy the elements at the time that we're copying, because maybe went in there, someone went in there and changed the element values, right? So that's what we need to do, and then we'll be able to fix that issue. Okay, and that is in the header. So then we come here and we will create another constructor. We have a const reference to our vector v, and this is known as a copy constructor. It's rule 1 of 3 for rule of 3. So this was inherited from legacy C++. And then we have actually already another rule that we created, and it's this one. So this would be rule 3 of 3, meaning we have some other rule that we need to cover. Okay, so what will the copy constructor do? If we visualize what we want to do, we're like, okay, we want to create new memory of the exact same size as v1, and we want to copy the values into the new memory, and we want to make sure that our pointer points to the new memory. That's what we're after. So if we come here, this is what we want to do. Copy here, right here. Okay, so let's put some comments here, and then we'll put that comment, and then we'll copy the constructor header, and we'll go and write some code. So make it part of our class. Initialize size for v2, initialize memory for v2. Okay, so initializer list, size, you get v.size. Even though we get member-wise copy, we want to be explicit. So meaning we want to chance it, like we want to take control. So we're like, okay. And elements, we want to create new memory, integer of v dot size. And once we do that, then we should be ready to copy some values, right? So v dot size. Let's see here. Initialize. Okay. So initialize size for v2 is this statement. Initialize memory for v2, this statement. Now we just need to copy elements from v1 into v2, right? So v is v1, okay? So then we say, oh, okay, so for size of t, I equals 0, I less than v dot size, increment I, elements at I equals v dot elements of I. So now we copy the values into the new vector that's been created. Once we do this, then we should be okay. Like our code should work. Okay, so we don't have to change anything here. We simply run the test case again. So run. And while that one's running, we'll go ahead and no copy constructor. And then this one is with so copy constructor implemented. It's the same code, so we'll copy this code. But now that we added the copy constructor code, we should be okay. So let's redraw this. So we have the stack memory, and then we have the heap memory. And v1 size, elements will keep the same address at y50. Zero, 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 point to that one. Okay, so now v2 equals v1, and now we fixed our code. So size will be 3. Elements now gets its own memory. So let's say this is what, 38, 34, 30, 26. Let's say that it gets memory starting at 34, so then this one will be y34. Copy the values. Let me see. Okay, yeah. So we're not doing that yet. Okay, so copy the values. So then all of them are zeros. 0, 0, 0, because all of these are 0. And then point to the new memory. We come back over here. So then v1 of 0 equals 5. So this one changes to 5, but this one doesn't, because now both vectors have their own memory. If we go back to the previous one, this one was being changed to 5 and both vectors were pointing to it. So that's why the test case failed. And if we come back over here, notice now up arrow space -s, enter. So now the test case passes. 5 is not equal to 0, meaning now both of them have their own dynamic memory, and that's what we were after. Any questions on that one? Okay. So we know this one requires or needs the copy constructor to work correctly. Otherwise, we have an issue where two vector instances are pointing to the same memory. With the copy constructor now, each of them point to their own memory. If we have another vector, v3, 3 elements, vector v4, excuse me, also with 3 elements, and then we say, okay, we want v4 equals to v3, and let's copy this code. Okay, so we have that code, and we will diagram those statements. Okay, I guess we can still use blue here. Stack. Heap. And that one's there. What's happening to this guy? Okay, well, they're playing nice with me. Okay, so we know that this one will be here, and size will be 3. We'll have elements. We'll have some memory. We'll stay white 50, 46, 42, 38. Okay, so we'll still use Y50 for this one. 0, 0, 0. And this one is 3, and elements. We'll still use Y34. 0, 0, 0. Okay, and now V4 equals V3. Let's make sure that we point to that one. So V4 equals V3. So we know that at least this one's going to stay the same, right? Because we get a free copy for stack variables. But what happens to this one? Any ideas? Let me create another test case. Okay, so 3 vector v4 v4 equals v3. And how do we check this one? Okay, so maybe here we say v3 of 0 equals 5, and then copy them, and then we say, okay, now I want to check. So require v4 of 0 equals or not equals. Let me see. So equals v3 of 0. Should they be equal or not equal? I guess equal, right? Because we're copying a value that we overwrote. Maybe we need to do it over here, right after. Yeah, so maybe we need to do it after. So we do it after, then the memory's already been copied, and then we can modify one and compare and see if they have two memory regions or they're pointing to the same region or what happened. Okay, so if we do it this way, then they shouldn't be equal, right? Okay, so okay, why is it complaining? Let me see. V4, V3, V3. Okay, I did change it. I can't see the error. Let me see. Okay, oh, capital V. I didn't see that. So, okay. I saw what I wanted to see. Okay, run in terminal. And building. Linking. So looks like we have that same issue, right, where the compiler tries to help us, but it ends up not helping us, right? So let's go back to our diagram and see what happened. So so what happened, right? So V4 equals V3, and we modified that one. We set equal 5, and then we did a comparison, and well, you saw the test case failed, right? So two things could have happened. Like it could have changed both of them, which we know is unlikely. So then it changed this one, but this guy, meaning like this guy, it doesn't point to Y34 anymore. Instead it points to Y50. What is that? Five bonus points on the final. If somebody can tell me what 34, 30, and 26 are after V4 equals V3 is executed. Someone got it right in yesterday's class, so. It's a memory leak. Yeah, Adrian, send me an email and just say that you answered the memory leak question for 5 points on the final. It's a memory leak. So our pointer is now pointing to other memory, and now we have no way of removing this memory. Like so we leaked memory, which is not good. So we need to fix that. So there are steps to fix that, right? So now we have to do all of these. Is that because you didn't write vector in front of V? Well, V4 already exists right here, you see? So vector V4, so we are overriding an existing variable. So V4 exists already. We're overriding it now with V3. And in the process of doing that, we created inadvertently, right, a memory leak. but we'll fix it. We have to, well, it says no copy assignment there, so now we have to create a copy assignment overload to make sure that we don't get into that situation when we execute that code, and then we'll get what we want. Like the pointer is pointing to deleted memory. No, this one's gone. You see, the X's means like when v4 equals v3 executes, right? So elements, this one now points to, is this the this is the wrong one, sorry. Control Z, this one's what's from yesterday, this one. So so you see the X's means it's not pointing here anymore, and now it's pointing to Y50, to the V3's memory. In essence, these are orphan elements or a memory leak. I mean, there's no way of us going back right now, the way the code's structured, to make sure that we delete the memory. Yeah, it was never deleted. So we need to fix that. Make sure that that doesn't happen. So even if the constructor, the destructor executes twice, it's gonna delete the memory one time, and then it's gonna try to delete the memory that doesn't exist again. So, which is not good, right? So we need to fix that. And then this one will stay out there unless we fix it. So. Okay, so, and that's rule 3 or rule 2 of the rule of 3, and that's the copy assignment. So we have to say, okay, return a reference to vector operator equals, so equals, and then a constant vector v. Copy assignment, rule 2 of 3 of rule of 3, and this was inherited from legacy C++. Okay, come here. And those are the steps we need to take in the copy assignment code to fix that issue that we have. So we come here and copy this, and we'll look at the diagram and see what we need to do, and then we'll implement that code. Okay, so when v4 equals v3 starts executing, we need new memory somewhere, 3 elements, okay? And then we need to copy the values from v3 into the new memory. And then we need to change this pointer to point to the new memory. But before we do that, we have to make sure that, well, after we do that, then we have to remember to delete this memory. And then we have to make sure that we change the size to explicitly. Once we do that, then we would have eliminated this issue when we execute those 3 statements together. And I will draw the diagram first to see exactly what we need to do. Okay, so copy assignment implemented. It's the same code. So now, hopefully now you all see like why we use string and vector and unique pointers before even worrying about creating dynamic memory for our assignments. I mean, and made for, the assignments as they are complicated with inheritance and polymorphism, and then imagine trying to remember all these tricks to dynamic memory, then that probably wouldn't go too well. So in other words, like use smart pointers whenever you can, right? So we know that this one will be V3 and V4, size 3 elements, Y50. Okay, 50. And let's say let's start at third. Okay, so I think now we have enough to do what we need to do. So size of 3 elements, and this one will still be pointing to Y34. Okay, so these 3 elements are 0, and this one points to that one. And then these 3 elements are 0, and this one points to that one. Okay, so that's vector v3 with 3 and vector v4 with 4, right, elements. Okay, so v4 equals v3. Okay, so we need to create temporary memory. Say it's 70, right? So use green. 0, 0, 0. So we create new memory, copy the values from 5046, right? Because this is v3 into the temporary memory. Okay, so we do that, copy to temporary memory, and then eliminate the pointer. Don't point to 34 anymore, instead point to Y70. And let's not forget to call delete to clear memory, so free that memory. And then we set size to 3 explicitly. And once we do that, then we're not leaking memory, and now both of them still have their own memory. Okay. What else? I think that's it. So that's what we want to do with code. Okay, let me see here. Is that the three rule? So that was rule 2 of 3, right? So if I go back to the header, rule 1 is the copy constructor. This one, I guess 3, right? 3 of 3. Yeah, sorry. So the destructor is usually number 3, and the copy assignment is the second one. So those 3 combined form the rule of 3, and that was inherited from legacy C++. And there's actually 2 more rules, which we'll cover in the next class. And then we'll have a full-blown class that's protected from hopefully leaking memory. And then we can after that we can do pushback, so that we can create a vector and add items to the vector. But notice here, all we've been doing so far is just managing memory, making sure that our class knows how to handle memory correctly. Okay. Create temp memory, copy values from V1 into new memory, delete elements, point elements to temporary memory, return a reference to, yeah, so we did that. Okay, so now let's write the code, right? So it's always good to talk about what we want to do before we start writing code, because sometimes when we do that, then sometimes we can hear ourselves out loud, and we're like, hey, wait a minute, that's probably not going to work. But in this case, this will work. So we say, okay, create temporary memory. What kind of memory? Well, we need an array, right? So new int of v dot size. So that's step one. Copy values from v1 into temp memory. Okay, so for size of ti equals 0, I less than v dot size plus plus I. Temp of I equals v dot elements of I. Okay, so that's step 2. Delete class v2 elements memory. So delete the memory, and then point elements memory to temporary memory. Okay, elements memory to temporary memory. Doesn't explicitly say, but we will say, okay, we want to make sure that we copy the size too. Okay, so, and then finally we're like, okay, return a reference to this vector. So recall the variable this, which is pointing to the class itself. So that in itself is like the class's name when it's in memory. So we will dereference it with this operator, and we'll say return this. Once we do that, then we've fixed our issue, and we've accomplished what we wanted to with this in this diagram, right? So, and this was the issue that we encountered, and we eliminated the memory leak. We went ahead and created new memory and copied values from v3 into the new memory, and we should be okay after that. So questions here? Okay, no new questions. Run in terminal. And it's building. Linking. So we're good, right? So we are good now. Everything's green. So 0 is not equal to 5, right? So which is what we were after, and that's what we wanted to cover, what I wanted to cover today. So in review, first thing we covered was the concept of a constructor and a vector complement. They work in pairs, right? So the constructor and the vector, they complement each other. We create memory in the constructor. We use memory in our class functions, and then we delete the memory in the destructor. And we went and showed some examples where we create an instance of a vector, and then from that instance we create a new vector, and we saw that we get a member-wise copy of size. Size is copied for free, and elements is also copied, but it's still pointing to the same memory of v1. So now we have v1 and v2 pointing to the same memory, which is not what we want, right? So if we come back and look at the diagram, we had this issue. after we add the copy constructor, then each vector had its dynamic memory, and then we're able to use v1 and v2 correctly, make a copy of v2 from v1 without any issues. And then we encountered this issue when we create two instances of vector, v3 and v4, and then we override an existing instance v4 from an existing instance v3. And number one, we have a memory leak, and number two, we have that same situation where two vectors are pointing to the same memory. So with a copy assignment, the rule 2 of 3 for rule of 3 in C++, we went ahead and added that code to fix the issue. And once we fix that issue, then we create temporary memory for the v4, and we make sure that we delete the old memory and we point to the new memory, and we copy the values from v3 into the new memory. Once we did that and we ran our test cases, we were okay, like it passed, right? So a lot of maintenance in memory management for classes, right? But that's okay, like that's the power of C++. And luckily the creators of C++ have these rules that if we follow, our programs have less opportunities to create memory leaks, right? So that's all I have for today. In the next class, we'll cover 2 more rules to make the rule of 5, and that's for C++ 11 and beyond. And we'll work on the pushback, and we will shoot for. Notice here how we create the vector. We're going to shoot for creating a vector like the standard library vector that can work with integers, can work with doubles or characters, and that's going to be our goal, right, for the next class. So we still have a lot to go through, but once we get through all of this, then you'll be ready to take on any concepts that are introduced to you in data structures, right? So there's no questions, and that's all I have for today. And